linear concurrence. Okay. A system of linear concurrence is a single variable concurrence with more than one concurrence. Okay. A system of linear concurrence is a single variable. Okay. Single variable concurrence with more than one concurrence. Okay. There are two methods to solve the system of linear concurrence. First one method of iteration. Then second one Chinese remainder theorem. Okay. Chinese remainder theorem, it is very important. Okay, there are two methods to find the system of linear concurrence. One of the method of iteration, then second one Chinese remainder theorem. Chinese remainder theorem, state and prove it. It is very important. Okay, now let's see the theorem, important theorem. Before I enter the problem, okay, let's see the Chinese remainder theorem. Okay, it's very important. Now the statement: the linear system of concurrences X concurrence to AI mod Mi. Okay. The Chinese remainder theorem. Now the statement of the theorem: the linear system of concurrences X is concurrence to AI mod Mi, where the modulo are pairwise relatively prime. Okay, where the modulo, okay, modulo, that is the pairwise relatively prime, and one is less than or equal to I, less than or equal to K, has a unique solution modulo M1, M2, M3, etc. Mk. Okay. Now see the concurrences. X is the variable. Okay, that is one of the variable. Now X is the concurrence to A1 into M modulus of M1. Okay. Then LHS. Okay, it is also X. X is concurrence to A2 mod M2. Okay, the next concurrence is next row. X is concurrence to A3 mod M3. Okay, etc. Up to X is concurrence to AI mod Mi. Okay, that is the right side. Right, RHS are various. Okay, that is A1 into mod M1, A2 into mod M2, etc. AI into mod Mi, but the LHS, okay, it is not various. Okay, it is the same value X. Okay, that is X is concurrence to AI mod Mi, where the modulo are pairwise relatively prime, and I is, okay, I lies between the 1 to K. Okay, now we have to prove it has the unique solution modulus of modulo of M1, M2, M3, etc. Mk. Okay, LHS வந்து various ஆகாது. Okay, it has the unique solution. Okay, X has the unique solution. We have to prove X has the unique solution of modulo. Modulo and the A1 constant மட்டும்தான் various ஆகும். Okay, A1 into modulus M1, A2 into modulus of M2, etc. AI into modulus of Mi. Okay, now we have to prove X has a unique solution modulo M1, M2, M3, etc. Mk. Okay, now let's see the proof. It is the statement of the theorem. Okay, statement வந்து important என்ன அப்படின்னா, that is the linear system of concurrences has a unique solution modulo M1, M2, M3, etc. Mk. Okay, இதுதான் important. Now let's see the proof. The proof consists of two parts. Okay, the proof consists of two parts. Okay, first proof. Before that, part 1, okay, before that, let M is equal to M1, M2, M3, etc. Mk. Okay, it is all the modulo M1, M2, M3, etc. Mk. Now here, Mi equal to, okay, M by Mi. Okay, M is that is the multiplication of the modulo M1, M2, M3, etc. Mk. Okay, mama. So Mi equal to, first consider the capital M is equal to multiplication of the modulo M1, M2, M3, etc. Mk. Then consider Mi is equal to, okay, generally that is Mi equal to multiplication of the modulo, okay, M capital M divided by Mi. Okay, now I lies between the 1 to K. Okay, that is I is equal to 1 to K. since the modulo are pairwise relatively prime. Okay va, already statement lay பார்த்தோம். Okay va, modulo are pairwise relatively prime. Therefore capital Mi comma Mi is equal to 1 for all I. Okay, also Mi is concurrent to 0 mod Mj where I is not equal to j. I வந்து not equal to j வா இருந்தா Mi, okay, that is Mi is concurrent to 0 mod Mj. Okay, this all the consider the first. The proof consists of two parts. First, consider M equal to multiplication of the modulo. Then Mi is equal to M divided by Mi, where M is equal to, that is the multiplication of the modulo. I lies between the 1 to k. Okay. Then we know that in the given statement, the modulo are pairwise relatively prime. Okay, so that Mi comma small mi is equal to 1 for all I. Okay. And also Mi is concurrent to 0, okay, mod Mj where I is not equal to j. Okay, I is not equal to j. Now first part 1, since Mi comma Mi is equal to 1, okay, Mi comma Mi equal to 1, the concurrence Mi comma into Yi is concurrent to 1. Mi into Yi is concurrent to 1 mod Mi has a unique solution Yi. Okay, that is since Mi comma Mi equal to 1, the concurrence Mi comma Yi is concurrent to 1 mod Mi has a unique solution Yi. Okay, now here consider, that is let x is equal to, okay, x is equal to a1 m1 y1. Okay, a1 into m1 into y1 plus a2 into m2 into y2 plus etc. ak mk and into yk. Okay, m1 m2 mk la enaduppa? Students, m1 m2 mk etc. mk la enadu? How can we find out the values of m1, m2, etc. mk? எப்படி find out பண்ணலாம்? m1, m2, m3, etc. mk. Students, m1, m2 லாம் எப்படி find out பண்ணலாம்? Capital M1, M2, etc. mk. How can we find out the values of m1, m2, etc. mk? Screen is visible ma? மேல பார்த்தே சொல்லிரலாம். Capital M1, M2 ல என்னதுமா? Hello. Same M1, M2, etc. capital MK is nothing but, that is Mi is equal to general formula. We know then Mi is equal to capital M divided by small mi. Okay, small mi ingiradu enama? Students, small mi
mod value ma'am.
Mod value is my good. Okay pa, இப்போ இங்க பாருங்க இதுல கொடுத்திருக்காங்க இல்லையா? இப்போ x concurrent to a1 into mod m1. அப்போ mi is equal to, okay pa, m1 m2 m3 various ஆயிட்டே வரும். Okay pa, for example m1 find out பண்றது அப்படினா I equal to 1 substitute பண்ணி பாருங்க. capital M1 equal to m divided by m1. சரியா? m ங்கிறது என்னமா? That is the multiplication of the modulo. Okay, so let x is equal to, here consider x is equal to a1 m1 y1 plus a2 m2 y2 plus etc. ak mk yk. Okay, now we have to prove that x is a solution to the linear system. Okay, that is x has a unique solution to the linear system. Okay, that is let x is concurrent to the summation of I equal to 1 to k, then I is not equal to j to k. Okay, I mi yi, okay, it is the general formula, plus aj mj yj. Okay, I equal to, okay, is a no summation I equal to 1 to k, then I is not equal to j to k. then ai into mi value வேணுமா I is not equal to j வா இருந்தா mi ஓட வேல்யூ என்ன
0.
0 okay then 0 okay see also mi is concurrent to 0 mod mj where I is not equal to 0 sorry j I is not equal to j bar that is the concurrence value mi equal to 0 okay so summation I is not equal to j ai into 0 yi plus aj into mj value okay that is equal to 1 mod mj okay then x is concurrent to plus aj mod j okay mj mj dama varum inga okay that is the mistake then x is concurrent to aj mod mj j is varies from 1 to k okay so x is your solution to the linear system okay so x is concurrent to aj mod mj okay it is the part 1 la enna pandrom appadina okay unique solutions வந்து இந்த மாதிரி எடுத்துட்டு then like x is considered of the constant mod m1 into y1 plus up to the ak mk yk எடுத்துக்கோங்க then x is here how to prove x is a solution to the linear system that is x is concurrent to summation okay ai mi yi plus aj mj yj அப்போ I equal to 1 to k then I is not equal to j to k I is not equal to j na mi value வந்து 0 okay substitute பண்ணுங்க that is enough then part 2 so x is a solution to a linear system prove பண்ணியாச்சு then we have to next prove that solution is unique modulo m அப்படினு prove பண்ணனும் ஓகேவா unique modulo m so then you consider here x0 let x0 and x1 with the two solution okay x0 and x1 with the two solution we shall prove x is concurrent to x1 mod m okay இதுதான் prove பண்ணனும் ஓகேவா x0 and x1 to be a two solution we shall prove x0 is concurrent to x1 mod m okay now here x0 is concurrent to aj mod mj okay mama we know that x is a solution to the linear system na enna x is concurrent to aj mod mj okay now here consider x0 is concurrent to aj mod mj then x1 is concurrent to aj mod mj okay then for j is varies from 1 to k that is mj is divisor of x1 minus x0 okay that is okay x0 and x1 is the two solution okay it be the two solution now we have to prove x0 is concurrent to x1 so then now here we know that okay in the previous part 1 okay x is a solution of the linear system x is a solution to the linear system that is x is concurrent to aj mod mj okay so here consider x0 is concurrent to aj mj and x1 is concurrent to aj mod mj okay that is mj is divisor of x1 minus x0 okay that is mj is divisor of x1 minus x0 for all j okay then also we know that mj is nothing but that is the multiplication of the modulo divisor of x1 minus x0 okay then we know that m1 m2 enama that is equal to m so idu eppadi eludhalam that is equal to capital M. So capital M is divisor of x1 minus x0 okay so x1 minus x0 is concurrent to 0 mod m then x1 is concurrent to x0 mod m okay so two solution of the linear system or concurrence modulo m okay appo the solution is unique modulo m idu rendume concurrence vanda x1 is concurrent to x0 two solution of the linear system or concurrence to modulo m okay therefore the solution is unique modulo m okay konja neengala padikra madha irukum purinju padichukonga okay let's see the example puriyadama 2 பார்ட்ஸா எடுத்துட்டு ப்ரூவ் பண்ணணும். ஓகேவா? எனி டவுட்மா? Shall we go to the problem? It's based on the Chinese remainder theorem. அது பார்க்கலாமா? Let's see the example based on the Chinese remainder theorem. Okay. Now using CRT, okay, that is Chinese remainder theorem, solve Sun-Shu puzzle. X is concurrent to 1 mod 3, then X is concurrent to 2 mod 5, and X is concurrent to 3 mod 7. Okay. Chinese remainder theorem statement enema? Anyone? Chinese remainder theorem statement. And the linear equation மட்டும் சொல்லுங்கப்பா. X is concurrent to students. Anyone more? Statement of the Chinese remainder theorem. Now solve the X is concurrent to 1 mod 3, then X is concurrent to 2 mod 5, and X is concurrent to 3 mod 7. Okay. Now we know that the statement of the Chinese remainder theorem, X is concurrent to A1 into mod M1. X is concurrent to A1 into mod M1. Then next row, X is concurrent to A2 into mod M2. Then X is concurrent to A3 mod M3, etc. X is concurrent to AK mod MK. Okay, it is this Chinese remainder theorem. Okay, statement of the theorem. Now here, using Chinese remainder theorem, solve the puzzle. X is concurrent to 1 mod 3. அப்போ A1 என்னமா இங்க? A1, A2, A3 எல்லாம் என்னப்பா? Students, A1, A2, A3 ma? Now the three equations are given. Okay, X is concurrent to 1 into mod 3. Okay, that is A1 into mod M1. X is concurrent to 2 into mod 5. That is A2 into mod M2. And X is concurrent to A3 into mod M3. Okay, so three values are given. So we know that given values are, first write the given. X is concurrent to 1 into mod 3. That is A1 is equal to 1, M1 equal to 3. Then A2 equal to 2. Then M2 equal to 5. Then A3 is equal to 3. Then M3 enama 7. Okay, so now here given modulo M1, M2, M3 are 3, 5, 7. Okay, we know that Chinese remainder theorem statement, the modulo are pairwise relatively prime. Okay, now here write the modulo M1 equal to 3, M2 equal to 5, and M3 equal to 7 or pairwise relatively prime by Chinese remainder theorem. Then the linear system has a unique solution. Okay, then Chinese remainder theorem statement. Okay, now to find M1 find out pannom. Okay, so capital M ங்கிறது என்னமா? Capital M. Students, capital M na என்னமா? The Chinese remainder theorem, what's the value of M? Capital M. Capital M na என்னமா சொன்னா? Hello. What's the value of capital M? Go through back the Chinese remainder theorem. See, Chinese remainder theorem statement. The linear system of concurrences X is concurrent to AI mod Mi, where modulo are pairwise relatively prime and I is lies between the 1 to K, has a unique solution modulo M1, M2, M3. Okay. Now, capital M is equal to capital M ங்கிறது என்னமா? Capital M. To find capital M. Hello. Students, capital M ங்கிறது என்னப்பா? Students, are you there? Hello. What's the value of capital M? Capital M that is the multiplication of the modulo. Okay, next we have to find the Mi. Mi is equal to, okay, Mi equal to capital M divided by small mi. Small mi modulo. Okay, capital M that is the multiplication of the modulo. Okay, so now to find capital M1, okay, now we are going to find the values of 3, that is capital M1, capital M2, capital M3. Okay, M1 equal to capital M divided by M1. We know that capital M is nothing but that is the multiplication of the modulo. Okay, now given modulus of 3, 5 and 7. Okay, that is the multiplication of the modulo 3 into 5 into 7 divided by M1. M1 is equal to 3. Okay, so 105 divided by 3 is equal to 35. So it is the M1 value. Then to find M2, okay, M2 is equal to formula capital M divided by M2, that is equal to capital M is the multiplication of the modulo 3, 5, 7 divided by M2. M2 is given, that is the 5. Okay. Then answer 21. Then M3, capital M divided by M3. Okay, capital M is the multiplication of the modulo divided by M3. That is answer 15. Okay, so M1 equal to 35, M2 equal to 21, then M3 equal to 15. Okay, next we are going to find the value of Y1, Y2, Y3. Okay, Y1 is the solution of the concurrence. Okay, then formula M1 into Y1 is concurrent to 1 mod M1. Okay, it is the formula for the to find Y1, Y2, Y3. Now Y is the solution of the concurrence. So M1 into Y1 is concurrent to 1 mod M1. Okay, M1 oda value enappa 35. M1 is equal to 35. Y1 is concurrent to 1 mod 3. Okay, then next எப்படி simplify பண்ணலாம்? 35 3 ஆல டிவைட் பண்ணா again simplify பண்ணுங்கமா. See, 35 is greater than of 3. Okay, so simplify பண்ணா என்ன வரும்? Remainder 1 வரணும். Students, 35 3 ஆல டிவைட் பண்ண ஆன்சர் என்னமா வருது? வருதப்பா ஸ்டூடெண்ட்ஸ் 35 y1 concurrent to 1 mod 3 ma. Okay ba, now remainder 1 varanum. Okay ba, 35 3 ஆல டிவைட் பண்ணா ஆன்சர் என்ன? Students,
2 ma'am.
2 ba, okay ba, so y1 is equal to 2. Okay, அதாவது ரிமைண்டர் வந்து 1 வர மாதிரி பார்த்துக்கணும். ஓகேவா? Okay, so y1 is equal to 2 mod 3. Okay, Then next m2 into y2, okay, concurrence to 1 mod m2, okay. m2 oda value enapa, m2 value enna 21, okay. So 21 into y2 is concurrence to 1 mod 5, okay. அப்போ இது 21 5 ஆல டிவைட் பண்ணோம், ரிமைண்டர் 1 வரணும்பா. y2 is 21 y2 is concurrence to 1 mod 5. 21 5 ஆல டிவைட் பண்ணா
1 ma'am.
ரிமைண்டர் 1 வருதா, okay. So y2 concurrence to 1 mod 5. Then m3 y3 is concurrence to 1 mod m3. m3 is equal to 15 y3 is concurrence to 1 mod 7. 15 7 ஆல டிவைட் பண்ணோமா, ரிமைண்டர் என்னப்பா வருது,
1 ma'am.
1, okay va. So y3 is concurrence to 1 mod 7, okay. So hence by Chinese remainder theorem, x is equal to, okay, x is equal to summation I equal to 1 to 3 ai mi yi, okay, mod m. Then a1 value la theriyalama, that is given, that our values are given. a1 equal to 1, a2 equal to 2, a3 equal to 3, okay. Then capital M is, we know that is the multiplication of the model of 105, okay. Now expand the summation, okay, put I equal to 1 to 3, okay. a1 into m1 y1 plus a2 m2 y2 plus a3 m3 y3 mod m, okay mama. So a1 value venna 1, m1 value 35, y1 is equal to 2, okay. Then a2 value 2, m2 is equal to 21, then y2 equal to 1 plus a3 equal to 3, then m3 is equal to m3 and about 15, okay. y3 equal to 1 mod, okay, mod capital M, that is equal to 105, okay. Simplify பண்ணனும், that is x is equal to 52 mod 105, okay. This is simplify பண்ணனும், சரியாமா. So the general solution x is equal to 52 plus 105 into t, okay, that is the mt. There is any doubt ma? First என்ன பண்ணுங்க, m1 m2 m3 value find out பண்ணிட்டு y1 y2 y3 find out பண்ணுங்க. Then Chinese remainder theorem, x is equal to formula summation I equal to 1 to 3 ai mi yi, okay. This substitute பண்ணுங்க, that is to expand the summation, okay. So x is equal to 52 mod 105, okay. That's the answer. Any doubt more? Next problem, same method no. The remainder 2 when divided by 5, then 4 divided by 6, 5 is divided by 11, 6 is divided by 13, okay va. So the remainders are given. So 2 வந்து 5 ஆல டிவைட் பண்ணும்போது ரிமைண்டர் வந்து 2, okay va. So linear formula எப்படி பண்ணலாம் எழுதலாம் அப்படினா, that is given x is concurrence to 2 is the remainder modulo 5, okay. Then x is concurrence to 4 is divided by 6, now that is x is concurrence to 4 mod 6. Okay, the next mod 5 is divided by 11. Okay, so 5 is the remainder modulo divided by the number 11. Okay, then x is concurrence to 6 modulo 13. Okay, same method Chinese remainder theorem use பண்ணி ஓகேவா. Okay, now student, please answer attendance. Adilakshmi. Students, please answer attendance. Adilakshmi.
Present, ma'am.
Okay. Aarti. Abhinav.
Present, ma'am.
Abhisheka. Adikesav.
Present.
Aksaya.
Present, ma'am.
Usasri. Anthony. Absent. Aravindan.
Ma'am, Abhisheka present, ma'am.
Abhisheka present. Aravindan ma absent. M Archana.
Present, ma'am.
C Archana. Arun Kumar. Aravind. Yes, Aravind.
Present, ma'am.
Vamsi Krishna.
Present, ma'am.
Bennipriya. Ulligita.
Yes, ma'am.
Parmadi. Tarun.
Present, ma'am.
Chandru. A Danush.
Present, ma'am.
U Danush ma. Divya.
Present, ma'am. Dhanush, you present, ma'am.
Divya.
Present, ma'am.
Dinesh pa. Absent. Godson.
Present, ma'am.
Gokula Krishnan.
Present, ma'am.
Gautam Raj.
Dinesh, present, ma'am. Present, ma'am.
Dinesh present. Okay. Gautam Raj present. Gunasegaran. N Hariharan.
Present, ma'am.
S Hariharan.
Present, ma'am.
Harshabardhan. Indira.
Present, ma'am.
Present, ma'am.
Okay, ma'am. Janavi.
Yes, ma'am.
Okay. Jayasuriya.
Present, ma'am.
Jeevan ma. Absent. Jeevita. Absent. Jitendran.
Present, ma'am.
Uday Kiran. Animoli. Karan.
Present, ma'am.
Kavita. Kirtana. Vaharan. Yogavarshini. Yogeshwaran.
Present, ma'am.
Madan Raj.
Present, ma'am.
Ma'am, Kavita present, ma'am.
Ma'am, Anthony Rosikal present, ma'am.
ஒரு நிமிஷம் இருமா. லோகேஸ்வரன்மா, லோகேஸ்வரன் யாருமா?
சந்துரு ஏ பிரசன்ட் மேம்.
இரு நெக்ஸ்ட் லாஸ்டா முடிஞ்சது சொல்லு சரியா. லோகேஸ்வரன்மா
பிரசன்ட் மேம்.
ஓகே. மதன்ராஜ்,
பிரசன்ட் மேம்.
மதுமிதா,
Present, ma'am.
யசுராஜு,
பிரசன்ட் மேம்.
மோகன கணபதி, மோகன கணபதி, மோனிகா, மோனிகா, விஜயபாபு,